Welcome to Chemistry Online. Today we're going to talk about chemical measurement and the mole concept. Remember that the mole concept was based on Avogadro's observation that equal volumes of any gas contain the same number of gas particles. Further, if we had 22.4 liters of that gas, the mass was identical to the formula mass of the element or compound expressed in terms of grams. Now what this means is that if you have a sample of a substance and that mass equals the formula mass, it will contain 1 mole of particles, that is 6.02 times 10 to the 23rd particles. We'll refer to this as the molar mass. For example, if we had 12 grams of the isotope carbon-12, that would contain 6.02 times 10 to the 23rd atoms of carbon-12. Now remember, carbon exists as isotopes, so the molar mass of carbon is what we see on the periodic table of about 12.01 grams per mole. The definition of Avogadro's number is actually based on the isotope carbon-12. If you have exactly 12 grams of carbon-12, it will have Avogadro's number of particles. Let's look at just a simple nomenclature concept here. Molecular weight. Molecular weight of a substance is simply the sum of the atomic weights of all the atoms in the molecule. For example, the amino acid glycine has a formula of C2H5NO2. To get the molecular weight, we simply add up the weights of each of the atoms, multiplied by the number of atoms, and in this case we get 75.07 atomic mass units. Remember, the molar mass is that expressed in grams. Therefore, the molar mass of glycine is 75.07 grams per mole. Now this is a very important concept. If you look at this little picture here, this balloon contains 32 grams of oxygen. The vial is 18 grams of water. We have calcium carbonate, we have 63 grams of copper. Each of these represents 1 mole of the compound or element. This is what's going to allow us to do simple quantitative calculations for chemical reactions. Let's look at a couple simple problems here. If I tell you we have 17.8 grams of magnesium hydroxide, what is the number of moles that represents? What we're going to do here is solve this using our given, that's the mass of our magnesium hydroxide, and we're going to take the molar mass as our ratio. The molar mass is 58 grams per mole. We, of course, have inverted that so that grams will be in our denominator. We multiply this out, and this represents 0.305 moles of magnesium hydroxide. Very simple problem. A mole contains 6.02 times 10 to the 23rd molecules. 10% of a mole contains what? Here we're going to use Avogadro's number as our given, and we're going to convert our 10% into a ratio. Remember, 10% really just means 10 parts in 100. We multiply this out, we get 6 times 10 to the 22nd molecules, and of course none of the answers correspond. One more calculation. Here we have a sample of carbon dioxide with a little bit over 21 grams. Our molar mass is 44 grams per mole. What we want to do is to figure out the number of moles of CO2. So we'll use our 21.5 grams as our given, and again our molar mass as our ratio. To get moles of CO2, we want to take our given. We have to invert our molar mass so that grams cancel. Do our calculation. and this is our calculator answer. Now this is an interesting problem because this gives us an example of rounding in a number that ends in exactly 5. In this problem, we're dealing with 4 significant figures. We have 5 digits on our calculator. The rule here is that you round so the answer is always even. Now remember, this only applies if your result ends in exactly 5. Now there are some tutorials dealing with moles, molar mass, whatever. The first one is very simple. You're just filling in a table. We're given a mass, we're given a number of moles, and we have to calculate the molar mass. Molar mass is simply going to be our mass divided by our number of moles. In this case, it turns out to be 100 grams per mole. Here we're given a molar mass and a number of moles. We want to calculate mass. If we take moles and multiply it by molar mass, we get the mass in grams, and this is 163 grams. The next tutorial takes this same concept and expresses it in a word problem. How many moles is 87.36 grams of copper? Well, we're given the molar mass. We know a mass. Always remember that mass divided by molar mass is going to give moles. One more here. We're looking for the mass in grams of 0.243 moles of lead. Our molar mass is given as 82 grams per mole. Mass is going to be given by moles multiplied by our molar mass, and this gives us 19.9 grams of lead. The third tutorial looks something like this. We have a sample of lithium nitride containing 1.9 moles of lithium. We want to know how many grams of our compound lithium nitride are present. Now the way this one differs from the others is that we have to use the mole ratio for lithium to lithium nitride. We are given a number of moles of lithium, so I put lithium in our denominator. We're going to multiply this by our given, and when we do, we get 22 grams of the compound lithium nitride. One more. We have a sample containing 0.598 moles of cobalt-3 oxide. How many grams of cobalt are present? Here again we have to do a mole ratio. We have 2 moles of cobalt for every mole of cobalt-3 oxide. Multiply that by our given, and we get 70.7 grams of cobalt.